Greetings, Algebra 2 students. This is Mr. Weber here. Today we got a nice, easy lesson for you on periodic functions. Now, I know you're looking at these pictures and you're thinking, this does not look easy, but I promise you, at the end, you're going to feel like, I got this. I do want to remind you that this comes from pages 381 to 390 in your textbook, so if you have questions, you can always go there as a resource. So, question, what is a periodic function? Okay, so periodic functions are functions that repeat exactly in regular intervals, which we call cycles. Okay, so it's the same thing that happens over and over and over and over again. The horizontal distance from one cycle to the next is called its period. So you may have talked about these in science as like wave functions, but they don't have to necessarily be waves and rounded. They could be more straight, almost like absolute values. The key is that they have to repeat over and over and over and over again. So the picture on the left, that is a periodic function because you can see that it goes, it repeats the exact same height, the exact same depth, so the maximum value and the minimum value are exactly the same, but it's also that it's happening consistently at the same period. So the distance between every point on one cycle to the exact same point on the next cycle is the period. All right, so we measure the period, or in science you might have called this like the wavelength. But in math, we're going to call it the period. We measure it as the distance from a point on one cycle to the exact same point on the next cycle. So you can see we can measure it from the top of the wave to the top of the wave, from the middle of the wave going up to the middle of the wave going up. So it's got to be the exact same point on each cycle, or from the bottom of the wave to the bottom of the wave. So again, if people say waves, these are, we'll say cycles, but wave cycles, same idea. Okay, so here's our big task for the day. So we got to look at a graph and be able to determine, first off, yes or no, is this function periodic? And then if it is, we got to be able to identify some of the key features of that graph. And it's going to be pretty straightforward, I hope. First off, the graph that we see here, is it periodic or not? So is the height the same? Yes. Is the bottom, the minimum, the same? Yeah. Okay, does it seem to be happening at a consistent rate? And it does. It looks to be spread out at about the same distance from the high point to high point, low point to low point. So we're going to say yes, this is a periodic function. All right, so let's find out what the period is. All right, so the period is 8. Now, how did I find 8? All right, so that is going to be the distance from the point on one cycle to the same point on the next. So just for convenience sake, I took the highest points. But here's what you have to remember. We always measure the period in terms of the distance on the x value. Okay, so the maximum height here is +2, but we're going to say the period is 8 because it starts at -4 and it ends at +4. And if I were to count from -4 to +4, it would be a total of 8 units. Okay, so this distance here is 8, which is why my period is 8. Okay, what's the maximum value? Well, so I'll just put a little note here. Period, we always measure by the x values. All right, so that's going to be different from the maximum minimum, because maximum minimum, we're going to look at the y values. So where is the maximum? Or what is the maximum? What is the minimum? So the maximum is going to be 2. So here's our maximum point. We trace that over to +2. What's the minimum? Minimum is -2. And again, we trace that minimum value over to the y-axis. It's at -2. Okay, so periods we measure based on the x-axis, max and min we measure based on the y-axis, where they are on the y-axis. Okay, what is the range? Well, the range is just the distance from the maximum from the minimum. So go straight to the y-axis and just count from that high point to the low point, and that would be a total of 4 units. Okay, so there's my high point at 2. Here's my low point at -2. The distance inside there is 4 units. So far, so good? All right. Here's where things can get a little tricky. The horizontal line that runs midway between the maximum and minimum values is called the midline. All right, makes perfect sense. Key with the midline is, 1, it has to be directly in the middle of your periodic function. But 2, we're always going to ask you for the equation of a midline. All right, so the first thing you got to think is this midline going to be a vertical line or a horizontal line? Yeah, it's going to be a horizontal line. Now the next question is, horizontal lines, what variable do those equations start with x or with y? Oh, I always mess this up. If you said y, you're correct. All right, so there's our midline. This is the point that is directly in the middle of -2 and +2. It's going to be at 0. And you can always test your midline by asking yourself, let me just look at the amount of space I have above and below. So above, I would go up 2 units to get to the top point. And now you go down. How far down do you go to get to the bottom point? Also 2 units. If that's not the same, then you're not in the middle. All right, so the midline's exactly in the middle. And yeah, so we're going to say it's at y equals 0. It's an equation. It's horizontal. Starts with y. Always, 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 always. Cool? All right. Last one. Last definition piece. The amplitude of a periodic function is half the distance between the max and the minimum values. All right, the amplitude is half the distance between the maximum and minimum values. Now that sounds like it's going to make things a little complicated, but it is actually pretty straightforward and pretty easy, because look, we already found it. When we tested our midline by saying, how many did we go up? Oh, that was 2, right? How many did we go down? That was also 2. Guess what our amplitude is? That's the amplitude. It's the distance from the middle, from the midline, going up. And you can measure that on any of the cycles. So maximum value, minimum value, maximum value, minimum value, they should all be the same number. The key is most students try to mix up range and amplitude. All right, so don't fall into that trap. Range is from the max to the min, the whole distance. Amplitude is just half that distance. How far from the middle? So if you think about a wave, I should say a cycle, but you guys make sense, waves make sense to you. If you think about a wave, how far up does that go? How far down does it go from the middle, from sea level? That's what we're talking about. Okay. All right, here's your practice. We got 4 practice problems, and then we are done for today. This is going to be out in record time as compared to last week. All right, so here we go. I'm going to do number 2, and I'm going to encourage you to pause the video and do number 3 on your own before we jump in and answer it. All right, but here we go. Number 2, periodic, yes or no? We'll take a look at this. Do they all appear to be at the same height? Yes. Do they all appear to be at the same low point? Yes. So the maximum value and the minimum value appear to be the same. Is this graph kind of spread out evenly? Does it appear to be happening at the same kind of rate or frequency? And I'm going to say yes. So I'm going to say yes, this is a periodic function. And because we answer yes, we've got to answer all of these other things underneath. All right, so what's the period? All right, so let's find a point and measure it from one point on one cycle to the same point on the next cycle. So there's lots of different places you can do that. I picked these top 2 values here. Remember, period always goes by the x. Okay, so where is this starting? It appears to be starting right here at -3. Where does it end? This next one is here at 0. So we're asking ourselves, what is the distance between -3 and 0? All right, so period is always going to be positive. It can never be negative because we're measuring distance. It's the distance from one point on one cycle to the same point on the next cycle. And because it's distance, it's always positive. So -3 to 0, that's 3 units. That's our period. Done and done. All right, most students don't have a hard time with the maximum value. Just make sure you know what to look for. All right, so there's our maximum value, but the maximum is 6 because now we're going to trace it over to the y-axis. Okay, the minimum value is -2. So we take that bottom point, trace it over to the y-axis, and it's at -2. So our range is going to be everything from 6 to -2. All right, so if you were on a number line and you had to walk from +6 to -2, you would take 6 steps to go from 6 to 0. That's 6 steps. And you would take 2 more steps to go from 0 to -2. So 6 and 2 is a total of 8. Now, Mr. Weber, couldn't you just take the maximum, which is 6, and subtract it from the minimum, which is -2, as long as you remember that when you subtract a negative number, those two negatives are going to turn into a positive. 6 plus 2 is 8, and guess what? That's the range. So far, so good? All right, now, here's the question. Where's the midline? Well, you could eyeball it, and lots of students do that, and they get it right most of the time, but I would encourage you not to do that. I would not just try to look at it and try to guess where you think the middle is. I would try to make sure you're doing this right. If you know the range, that's 8, then if we cut that range in half, so if we take 8 and divide it by 2, that should tell us how far we have to walk from the top or from the bottom to find the midline. So we're going to take this range and we're going to say 8 divided by 2, and that's 4. So that means I should walk 4 units from the top. So from 6, I should walk down 4 units. And from the bottom, -2, I should walk up 4 units. And I should meet in the middle. So where's that going to be? It's going to be at y equals +2. And if you're ever not sure, just measure that distance from that midline up and that midline down and make sure that it's the same. Okay? Now, amplitude. Extra question, but you already did the work because you already found out what that distance is from the middle up and down. You did that as soon as you took your range and you cut it in half. All right, so this 4, that is the amplitude. Okay, so you can always take the range, cut it in half, and that should be your amplitude. Okay, now I encourage you to hit pause on the video real quick. Try number 3 on your own, and when you're ready to check your work, go ahead and hit play. Remember, if you get some of this wrong, don't get upset. We're learning, and that's how we learn. We have to make mistakes before we realize what the right way to do it is. Okay, so here we go. Are you ready? All right, so we're going to look at periodic functions now. We're going to look at number 3. Is it periodic? All right, are the maximum values the same? Yes, they appear to be the same. Are the minimum values the same? Yes, they appear to be the same. Does this cycle seem to be repeating at a constant kind of distance or width? And I would say yes to all those questions. So I would say yes, this is a periodic function. All right, so what's the period? So let's look at the distance from one point to the distance on the next. So it's always great if you can start at 0. It makes it easy. So we're going from 0 to 8. So the period is 8. Remember, we're tracing that back to the x-axis. All right, that first point is that when x is 0, and the second point is when x is 8. So from 0 to 8 is a distance of 8. What's the maximum value? That's 2. What's the minimum value? -4. All right, the range, 2 to -4, That'll be a total of 6 units. All right, and here's the one where some people, if you get this wrong, I'm betting you're going to get this. This is the one you're going to get wrong, and that's okay. All right, so how are we going to do it? We're going to take this 6 and we're going to cut it in half. We're going to say 6 divided by 2 is 3. So that means my equation is y equals 3. I know some of you guys did that. That's not right. All right, so 3 is not the midline. 3 is the distance we have to walk. We have to move from the max and the min to find where the midline is. All right, so if we take -4 and we go up 3 units, 1, 2, 3, here's where we are. This is where that line should be. If we take our maximum value and we go down, 1, 2, 3, this is where we are. Hopefully you can see that they line up on the same line. So the midline's not 3. 3 is the distance we have to move. So 2 minus 3 is -1. So -1 is where our midline is. So y equals -1. Okay? No thinking to find the amplitude because we just did that. When we said 6 divided by 2 equals 3, there's the amplitude. All right, most students confuse that with the midline. Don't do that. All right, how'd you do? Did you get it right? I hope you did okay. Let's try number 4. 2 more, we're done. All right, you're going to love number 4. It's the best one ever. All right, periodic, yes or no? So first off, do our maximum values appear to be the same? Well, no. These maximum values tend to be getting higher. Are the minimum values the same? No, they're definitely getting lower. Guess what that means? This is not periodic. And guess what that means? We don't have to do any of those other questions. All right, we only answer those if the answer is yes. So if the answer is no, you're done. Mr. Weber, can the answer always be no? Of course not. It'll mostly be yes. But every now and then we're going to throw one at you to make sure you're paying attention. So if it's not periodic, there's nothing you can say about it. Just say it's not periodic. All right, number 5. Pause the video, try it on your own, and then come on back and I'll show you the answers. Okay, here we go. Is this periodic? Are the maximum values the same? We can't see more than one maximum value, but it certainly appears that way. Are the minimum values the same? Yes, and it appears to be spread out, so for argument's sake, we'll say yes. If you said that this arrow meant that this was going on up, 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 up forever and ever and ever, I get it. I wouldn't mark it wrong on a quiz or a test because you would need to see more cycles to be certain that that's what's happening. So if you were thinking that, I understand. But for argument's sake, we're going to assume that this is going to be a periodic function that we can keep on going. Ideally, you'd want to see more than 1 or 2 or 3 complete cycles before you could say for sure that it was periodic. All right, so let's assume that this is periodic. Let's find the period. So the easiest place to find it, I think, is looking at the minimum value in this case. All right, so this is going to be a little tricky. So where is this starting? It's starting at -10. All right, so if I trace this point up, -10 on the x. Where is it ending? Over here, trace this up at +6. So it goes from -10 to +6, and that's a total of 16 units. So our period is 16 units. Okay, what's the maximum value? Easy peasy. Maximum value is 2. Minimum value is -8. Okay, so how far is it from 2 to -8? That's not right. It's not 6. What was I thinking? Goodness gracious, Weber. I was just making sure you guys are paying attention. Sometimes I like to throw a mistake in there on purpose, just, you know, otherwise you wouldn't know. So here you go. The range is 10. So from 2 to -8, that would be a total of 10 units. Let's go ahead and find the midline. So we take that 10 and cut it in half. So that would be 5. Remember, that's not the midline. That's the amplitude. What we have to do is take that 5, and I think it's easier here from -8 to go up 5 units. 1, 2, 3, 4, 5. There's our midline. It should be right there, which is at -3. So y equals -3 is the midline. And of course, the amplitude we just said was 5. Okay, If any of that didn't make sense, feel free to watch the video again. Feel free to reach out to your teachers. We are still here for you. But what you got to do on this unit is identify periodic functions, being able to find the period, the maximum, the minimum, the range, the midline, and the amplitude. It sounds like a lot, but when you look at the graphs, it's pretty straightforward. If you have any questions, please don't hesitate to reach out, and good luck.